Okay, what we're going to do now is we're going to do a quiz review for the quiz that's on Monday, which is over chapter 11.7 to 12.4. Okay, your quiz is on Monday. First of all, the first two types of questions that will be on your quiz is called divide the polynomials. What they want you to do is they want you to divide each of these polynomials. Remember, the word polynomial just means it has many terms by whatever they've told you. So they want us to divide 4x squared minus 3x plus 1 by x minus 2. And in the second one, they want us to divide this by 5x. So I've got to determine, first of all, what type of division am I going to do? Am I able just to write what I'm dividing by underneath each term, or do I have to do long division? And this is how you know. If what they ask you to divide by has more than one term, you have to do division. If what they ask you to divide by only has one term, you can just do the simplification process where we write it underneath. So first, let's do this one, the first example. I need to divide all of these by x minus 2. And I know I cannot write it like this because there's nothing I can do to simplify like that. There's nothing that will cancel out. So we do long division. So I write x minus 2 divided by 4x squared minus 3x plus 1. Okay? This is all you have to do in this. And I want everyone to pay attention because a lot of you just make little careless mistakes that on the quiz, since it's all or nothing, will really hurt you. Okay? You may accidentally put a minus sign or you may put the wrong number. So pay attention. This is all you have to do. Is I ask myself, what do I have to do to x to make it identical to 4x squared? What do I need to multiply by? I need to multiply by 4 and x, because there needs to be two x's, because this is x squared. Where you write it is above its like term. So I can't write it over 4x squared because they're not like terms. I write it over 3x. Then what I do, and this is what a lot of you forget to do, I've got to multiply this 4x by everything here. I've got to multiply it by the x and the minus 2. So I do 4x times x is 4x squared. And the whole point is to get those identical. Then 4x times negative 2 is negative 8x. Now, this is the part that you have to remember. What do I do now? Seth? Change the signs. Perfect, okay? I make this a negative and this a positive. All right? Whatever the sign is, you just change it. The whole point is to get these terms to cancel out. If your first terms don't cancel out, you've done something wrong. Then I just add the last terms. Negative 3 plus 8 is 5, and I keep the like term, which is x. Bring down my next term, which is 1. So now I ask myself, what do I need to do to x to get it to become exactly 5x? Multiply by what? 5. Very good. Okay? So, I take this and I add 5 right here. And remember, since you're trying to get it to become identical, I've got to multiply by a positive 5. I don't want to multiply by a negative 5, but multiply by a positive 5. And that's why I put that plus sign there. So I'm going to erase some of this quickly so that we have room. So I get 5 times x is 5x. Whoops. And then 5 times negative 2 is negative 10. Again, don't forget I've got to multiply by that 5 by everything. I change my signs, make this a negative 5 and this a positive 10, and they cancel out. 1 plus 10 is 11. So I'm left with a remainder of 11 because there's nothing else I can bring down. There's nothing I can do to make x 11. Okay? So I write plus 11 over, and I write whatever I divided by, x minus 2. And this is my final answer. That's how you use long division in order to simplify divide the polynomial. Okay? So let's do the next one. I've got 5x squared minus 25x plus 7 by 5x. So what you want to do here is, I know they just want me to divide a single term. So that makes it really easy for me because all I need to do is simplify. I write this over 5x, this over 5x, and this over 5x. And then I can just simplify the fractions. And the only reason I can do that with this problem, and I couldn't do it with the first problem, is because the first problem asked me to divide by two terms, x and minus 2. This one only asked me to divide by 5x, okay? So I asked myself, what number goes into 5? What number goes into 5? 5. 5 goes into 5 one time. 5 goes into 5 one time. How many x's can I cancel out? 1. So I cancel that x out, and I'm left with 1 on the top. So I've got 1x. It's my new first term. What number can go into 5 and 25? 5. 5 goes into 5 one time. 5 goes into 25 5 times. What do I do with my x's? Cancel them out. Okay? Then I'm left with negative 5. Okay? And then, do I have any x's left at all? No, they were able to cancel out. Okay? So then, let's look at this last term right here. Is there anything I can do to simplify 7 and 5? Any number that will go into both of them? No. Is there anything that I can cancel this x out with? No. So guess what? I leave this as 7 over 5x. There's absolutely nothing I can do to simplify it. So that is my final answer. Okay? Okay, the next type of problem that's going to be on your quiz is called multiply using the LCD. And the headings that I've given each of these slides are the exact instructions on the test. So you know you're not going to see anything different. It's not going to be anything new, okay? Multiply using the LCD. First of all, who can tell me, what does LCD even mean? Least common denominator or lowest common denominator. So I've got to find out, what is a good common denominator for all of those? First of all, ask yourself for a number. What number should they all be? Cortez? 5. Very good. We need to put the 5s. Each one that doesn't have a 5, I multiply by 5. Whatever I do to the bottom, I've got to do to the top. And what variable do they all need to have? Josh?
X.
X. Very good. So I look for the one that doesn't have an X, and I multiply it by X. Now, listen. Once you get the common denominators, you are able just to cancel out the denominators. Because it's an equation, I can do that. I'm just trying to solve for x. I'm not trying to find the answer to the actual addition problem because I already know that it's going to be 5 over x, all right? So this is all you do. 2 times x is 2x, plus 3 times 5 is 15, equals 5 times 5, which is 25. So now, all I'm trying to do is solve for x. So what should I do? Subtract 15. Very good. Subtract 15, and I get 2x equals 10. Then I just divide by 2, and x equals 5. That's my final answer. That's exactly how you multiply using the LCD in order to find a variable. Okay, the next example. Find the domain of the function. Now, if you remember, whenever we did this section, most of your homework came from problems that I just wanted you to find the domain, but then there were some that you had to find the domain, range, and graph. On the quiz, you will only have to find the domain. But when we do our test review, okay, we will go over graphing because there are some on the test that you will have to graph, okay? Remember, in order to find the domain, all we need to do is I need to figure out, okay, there can never, ever, ever be a negative number underneath a radical. I can never end up with a negative number. So if I figure out, okay, what would I have to plug in for x in order for underneath the radical to equal 0? That way I know whatever number I plugged in, as long as I don't plug in a number that's smaller than that, it will never equal a negative number. So I ask myself, okay, what minus 6 equals 0? 6. So I know as long as x is greater than or equal to 6, I will never, ever get a negative number. Because I can plug in 6, I can plug in 27, I can plug in 85, I can plug in 7, okay? I can plug in any number that's greater than 6, and I'll never get a negative number. But I'm telling myself, if you plug in a number that's smaller than 6, you will get a negative number. Because if I plug in a 5 here, 5 minus 6 is negative 1. And I'll end up with a negative 1, which I do not want. So that's exactly how you find the domain. There's nothing else that you need. Okay? Okay, now this is where most of the bulk of your test is. So we've got 3 questions on this. This section has more questions than any other section. And they want us to simplify the radical expression. All right? What I know in order to add or subtract any radicals is they've got to have a common term, okay? That common term means the number underneath the radical is identical. So like in order to add, I would have to have all of them be the square root of 3 or the square root of 5 or whatever it is, but they would all be the same. Well, I look at this. I've got the square root of 24, the square root of 96, and the square root of 6. Are any of these the same? No. So I know right off the bat there's absolutely nothing I can do to add them. But can I simplify 24 and 96? Yes, by doing upside down division. So that's what I've got to do first. So I take 24 and I do upside down division. What's the smallest number that will go into 24? 2. So I do 2. 2 divided by 24 is 12. Divide by 2, and I get 6. Again, divide by 2, and I get 3. Now, this is what you do here. I look for a pair of the same number. Oops. Okay? I've got a pair of 2's. What that means is that pair becomes 1, 2 that I can take out of the radical. I can put it on the outside. 2 does not become 4, okay? It doesn't become 2 plus 2, or it doesn't come 2 times 2, which is 4 also. It just becomes 1, 2. And I can put that on the outside of the radical. Now, what am I left with? A 2 and a 3. Whenever you're left with more than one number, all you do is multiply them together and get 6, and that has to go back underneath the radical. Okay, now I need to simplify 96. So I say, what's the smallest number that can go into 96? 2. 2 goes into 96 48 times. Divide by 2 again, and I get 24. 2 again, and I get 12. 2, 6, 2, and 3. Okay, now I need to circle my pairs. A pair of 2's, a pair of 2's. So this pair equals 1, 2. This pair equals 1, 2. What do I do to those 2's before I put them on the outside? Multiply. You always, anytime you get more than one pair of anything, you always multiply. So 2 times 2 equals 4. I can't forget my sign, so I do minus 4. And then I have to put underneath the radical what I have left. I have a 2 left and a 3 left. So I multiply those together and put them back underneath, which is going to be 6. Plus the square root of 6. That is simplified. There's absolutely nothing I can do. But somebody tell me, what is the number in front of this that I don't see but I know is there? 1. Go ahead and write that, because when it comes time to adding, you'll forget it's there and you won't remember to put it in your answer. Okay, so now since they're all like terms, all I do is add the numbers in front of them. 2 minus 4 is negative 2. Negative 2 plus 1 is negative 1. Then, since they're all like terms, I keep that like term and make it the square root of 6. I would not make it the square root of 18, okay, because I don't add those together. I don't multiply them together. It stays the exact same. Okay, this next problem, well, should have had a parentheses right there, okay? What do you think they want us to do here? What does it look like they want us to do? Distributive property, which is exactly what they want us to do. So they want me to distribute this square root of 3 to this, and to the 6. Okay? When you multiply a square root, they've got to both be under the square root in order to multiply them. I could not multiply the square root of 3 times 5 because they're not like terms, okay? And so I cannot, well, one's a whole number and one's a radical, so I can't multiply them. That's why I can't do it, not because they're not like terms, okay? You can only multiply things together that are both under the radical or that are both whole numbers. So I multiply 3 times 2, which is the square root of 6. It's got to stay under the square root. And since I did not multiply the 5 by anything, I keep it just where it is. Now, can I multiply 6 and the square root of 3? No. The 6 is a whole number and the 3 is a square root. So this is all you have to do to write it. 6 times the square root of 3. I write them side by side because 6 has got to go outside where the whole numbers go, and the square root of 3 has to go right behind it where the square roots go. These are not like terms. I cannot add 5 plus 6 and get 11 because I've got the square root of 6 and the square root of 3. So that is my final answer. Okay? Now the last type of radical problem. Am I ever allowed to have a radical in the denominator? No, never. How do I get it to go away? Callie? Exactly. I want to multiply by exactly what is in the denominator. In this case, it's the square root of 3. Whatever I do to the bottom, I've got to do to the top. Okay? What is the square root of 3 times the square root of 3? 3, exactly. It's always a whole number. Then I do 3 times the square root of 3, which, again, they're not like terms, so I write the 3 on the outside and the square root of 3 right behind it. What can I do now? Simplify. I can cancel those 3's out. They're both whole numbers. Now, I could not cancel the square root of 3 and 3 out because those are not like terms, okay? But I can cancel the whole numbers out. And I'm only left with the square root of 3, which is my final answer. Okay? Okay. So the next type of questions are solve and check the equation. So what I want to do is I'm looking to find x. But if you remember on these, I can find what x equals, plug it back in to check it, and figure out that it's not going to work out. So that's why you have to check. It is absolutely necessary that you check your answers because you may find out, well, what I got that x equals doesn't work. So my answer would be no solution. Okay? But before we do any of that, what has to be on one side by itself? The radical. So I circle it and I find out, okay, there's a 3 over there on the same side. So I need to subtract 3 in order to get that radical alone. I get the square root of 2x minus 3 equals 4 minus 3 is 1. Now, how do I get that square root sign to go away? Square it. Very good. Square this, and whatever I do to one side, I've got to do to the other. That squared, remember, just cancels out the radical sign. It just cancels out the radical sign. It does absolutely nothing to what's underneath. So now I've got 2x minus 3 equals, what is 1 squared? 1. 1 times 1 is 1. 1 times 1 is not 2. Please do not put that on your test. Okay? Then I just need to solve for x. So I add 3, and I get 2x equals 4. Then I divide by 2, and I get x equals 2. Now, you need to check this, and I've already told you this when we were doing the lessons. You can plug it in your calculator to check. But remember, once you check it, I want you to put whatever you got that is equal to whatever it was equal to at first. So I go back to the original problem here, and I say the square root of 2 times, instead of putting that x in, I plug in what I found x to equal, which was 2, minus 3, then plus 3. And remember, this plus 3 is outside of the radical, so don't put it underneath, equals 4. So I get 2 times 2 is 4, 4 minus 3, and I get plus 3 equals 4. 4 minus 3 is the square root of 1, plus 3 equals 4. Square root of 1 is 1, 1 plus 3 equals 4, so I do know that 4 equals 4. Again, if you plug it in your calculator, at least write that right there, so I know that you did, in fact, check it. So I checked 4 does equal 4, so I know that x equals 2 is my answer. Okay, now let's do the next one. What can be the only thing on this side? The radical. So I need to subtract 6. Square root of x equals negative 6. What do I do now? Square it. Cancels that radical out. Whatever I do to one side, I've got to do to the other. X equals, what's negative 6 squared?
36.
Positive 36. Okay, now I'm going to plug it back in and check it. Square root of 36 plus 6 equals 0. What's the square root of 36? 6 plus 6 equals 0. What's 6 plus 6? Does 12 equal 0? No. So I know that even though I found x equals 36, it does not work out. So this is no solution. That's exactly why you have to check these problems, because you may find out that it does not work out in the end. It's no solution. Okay, the last type of problem that we're going to do is completing the square. This is what we did yesterday. Remember, on completing the square, x squared and 4x has to be by itself on one side of the equation, and I know it is. So I do x squared plus 4x. What is going to go in parentheses here? This is what I have to add in. 4 over 2 squared. So what you do is you take b right here, and I put the b in, which is 4. I will always divide it by 2 and then square that answer. Then whatever I do to one side, I've got to do to the other. And I get x squared plus 4x. 4 divided by 2 is 2. 2 squared is 4. All right? On this side, 8 plus 4 is equal to 12. On this side, remember, I have to factor it. It will always be in parentheses squared. My first term will always be what? X. The last term, or what do I know my sign's going to be? Plus, because whatever b is, whatever the sign of b is, that's what I know what my sign comes from. And then what is the square root of 4? 2. That's how I find out what the last number is. Now, how do I get x by itself? What do I need to do first? Square root. Square root, square root, and I get x plus 2 equals, the square root of 12 can be simplified. So you have to simplify it, which is going to be plus or minus. Remember, you have to have that sign. The square root of 12 is going to be 2 times the square root of 3. Okay? Then all I need to do is subtract 2 on both sides, and I get x equals negative 2 plus or minus 2 times the square root of 3. Now, I could not simplify 2 plus 2 and 2 minus 2 because they're not like terms. So that would be your answer for completing the square.